Chapter 8, we're going to get into quadratic expressions and equations. So you don't really know what quadratic expressions are yet probably, but that's the big picture of what Chapter 8 is going to do for us. These are our objectives. We will add, subtract, multiply polynomials. We've talked a little bit about polynomials already. We're going to factor trinomials. We'll factor difference of squares. We'll graph quadratic functions, and we're going to solve quadratic equations. And again, this is all big picture stuff. You're not even sure what most of this means yet, but just to put the roadmap in front of you, Chapter 8, and this is what's coming. So let's jump in here to Section 1, adding and subtracting polynomials. So here's what we're doing today. We're going to write polynomials in standard form, and we'll be adding and subtracting polynomials. Okay. So just as a reminder, let's go back and grab some vocabulary that you may or may not remember. But we started off Chapter 7. We talked a little bit about monomials, and this was our definition. A monomial is a number, a variable, or the product of a number and one or more variables. And we said we had to have non-negative integer exponents. In other words, those exponents that we do have can't be negative, and they have to be positive and negative whole numbers. And really, since we're non-negative, right, those integer exponents can only be positive whole numbers. So that's what it takes to be a monomial. We talked a little bit about this, but a polynomial simply says we've got more than one monomial, right? But we can't be multiplying because that would just be a bigger monomial. A polynomial says we're going to be adding monomials. Okay, now let's look at a couple of monomials here. Specifically, a binomial says that we've got two monomials. So 2x squared is a monomial. It's the product of a number and a variable, non-negative exponents. So this is a monomial. 3 is a monomial. It's a number, right? It fits into that special category of a constant, but it's a monomial. So these are both monomials. So 1, 2, binomial. Okay? We could also have 3 terms, right? So we could have the sum of 3 monomials. And I hear what you're saying. That's a subtraction sign, right? But plus a minus, right? We'll talk a little bit about that. So x cubed is a variable with a non-negative exponent. Negative 10x is the product of a number and a variable. 6, again, another one of those special monomials. 1, 2, 3 terms, trinomial. Above 3, we really just jump back up here and call it a polynomial. Okay, but these are special polynomials. They have names: binomial, 2 terms; trinomial, 3 terms. Okay. A little bit more kind of foundation before we actually jump in and start manipulating. The degree of a monomial is something we'll want to know about. And the degree of a monomial simply is the sum of the exponents of all of its variables. Okay, so the sum of the exponents specifically of the variables. So here are several monomials. Okay, so the degree of this monomial. Well, I don't see any variables, so the sum of their exponents has to be just 0, right? So this monomial has a degree of 0. Okay, well, what about this monomial? Product of 2 and x squared. The sum of the exponents, well, there's only one exponent, it's 2. And so that's its degree. 2x squared has a degree of 2. 5x cubed y, the sum of the exponents of the variables. 3 plus 1, this one has a degree of 4. And then 1 plus 1 plus 1, this monomial has a degree of 3. So being able to identify and recognize the degree of a monomial, that's going to come into play here. We need to be able to do that. And again, the sum of the exponents, specifically of the variables. So the degree of a polynomial is going to be the greatest degree of any of the terms in the polynomial. So here we go. Here's a polynomial. We've got 1, 2, 3 terms. So it's a trinomial, but it's a polynomial. So the degree of this term is 2, sum of those exponents. The degree of this term is 3, and the degree of our 9 is 0. So that means that the degree of the polynomial, the greatest of those, polynomial, spelling is tough tonight. The degree of the polynomial is 3 because it is the greatest degree of those 3 terms. Now, that's important, okay, because we want to be able to write polynomials in standard form. And standard form of a polynomial tells me that the terms have been placed in order from greatest to least degree. Okay, so the largest degree in the front, the smallest degree in the back. This tells me that we're getting ready to move terms around. So we're going to grab these single terms, these monomials, and we're going to change the order. The other thing we'll be interested in will be the leading coefficient. The coefficient that's up front. Once we get it in standard form, what is the number of the term that's at the front of this little train here? So standard form. So here we go. 4x cubed, so degree of 3, degree of 2, degree of 1, degree of 0. So we're in order, 3, 2, 1, 0. So this is standard form for this polynomial. The leading coefficient, the number that's up front, okay, is 4. Okay, so let's try another one real quick. So here we go, 5y minus 9 minus 2y to the 4th minus 6y cubed. So just a really quick look here. Degree is 1, 0, 4, and 3. Now standard form means I have to put these in order from greatest to least. So this one is the greatest, so that has to go in front. Now the sign in front of the number has to go with it. So negative 2y to the 4th goes up front. So 1, 0, 3. All right, so 3 is going to go next. Negative 6y cubed is going to go next. The 5y, that's a positive 5y. That one would go next. And then our minus 9, right, degree of 0. So this is standard form because we're in greatest to least order. 4, 3, 1, 0. Greatest to least. And then our leading coefficient then is the negative 2. What number is out front? And that's negative 2. Now all this will come into play down the road as we get into working with polynomials a little bit more. But we want to make sure we're laying a foundation. We want to make sure that we're kind of grabbing onto some of this early vocabulary to kind of ease our way along. All right, so let me give you one to do. This one is yours. Your instructions are to write the polynomial in standard form and then identify the leading coefficient. Okay. All right, so largest degree first would be negative 7y to the 6th. And I don't want to spoil the punchline, but we already have our leading coefficient, right, negative 7. So the next one would be the positive 5y cubed, the negative 2y squared, the positive 1y, right? We don't see that positive 1, but there is a positive 1 in front of y right there. And then we have plus 10. Okay, now let's make sure we're not missing anything. 1, 2, 3, 4, 5 terms. 1, 2, 3, 4, 5 terms. Okay, so they're all there. Degree 6, 3, 2, 1, 0. So that's in descending order, greatest to smallest. And then again, we kind of spoiled the punchline earlier, but there it is. There's your leading coefficient, is negative 7. Okay. Now, as we find sums and as we find differences, our answer should be in standard form. That's one of the reasons we talk about standard form. Now, in adding and subtracting polynomials, here's the phrase that's going to come up again and again, like terms. Okay, because when we're adding and subtracting, like terms is what we get to put together. If two terms have the same variables, and those same variables are raised to the same exponent, the same powers, okay, then those terms get to be combined. Those terms get to be put together, added or subtracted, depending on what we're doing at the time. Like terms get combined. So let's work through this example real quick. Okay, so 2x cubed, 2x squared. Are there any other x squared terms? There's a negative 4x squared. So we're finding the sum, right? We're adding these two things together. So the 2x squared is being added to the negative 4x squared. Now, adding and subtracting doesn't change the exponents, right? When we get done, if we have any, they will still be x squareds. 2 plus a negative 4 means I've got negative 2 x squareds. Okay. Now, the next thing we're putting together, right? We've got 5x's here. Are there any other x's? We're still adding, right? So 5x plus 6x. And that's a positive 6x, so there's no need to put parentheses there. 5 plus 6 is, now we've got 11x's. And we've got minus 7 plus 3. So minus 7 plus 3. Okay, combine those, the numbers, and we get negative 4. Now, standard form, greatest degree, least degree. Negative 2x squared positive 11x minus 4. Okay, and there's our sum. Now you try one. Okay, so 5x squared plus a negative 3x squared, 5 plus negative 3, 2x squared. The x's would go next in descending order, so negative 3 plus 6 plus 3x. And then the 4 plus negative 3, 4 minus 3 would be 1. Let's make sure that we're in standard form. 2, 1, 0. So that's standard form. And this is what you should have. Now, subtraction gets a little more interesting because we're subtracting everything, right? So, again, what terms can be put together? The 5x squared can be put with the negative 2x squared, but remember we are subtracting, so 5x squared minus a negative 2x squared, so minus a minus is plus, so we have 7x squared. We also have 4x minus an x, again that's a positive x, so no need for brackets. 4x minus x would leave us with 3x. And minus 1 minus 13 minus 14. Standard form, greatest to least, 7x squared plus 3x minus 14. Okay? Look back over it if you need to. And the next one is yours. All right, so 5x minus a minus 3x. 5 plus 3 is 8x squareds. Minus 3x minus 6x is minus 9x. And 4 minus a minus 3 plus 3. 4 plus 3 is positive 7. Standard form and simplified.